Hey guys, today we're going to look at direct variation. So a quick definition, direct variation, a lot of times people think of it as being directly proportional. So some real life examples of what varies directly. Our circumference is going to vary directly with the radius, meaning our circumference will change if our radius changes. The cost is going to vary directly with sales. So a higher cost means your sales will decrease, okay? And then the last one, your distance traveled is going to vary directly with the time spent traveling. So the further you drive means the longer you've been driving. Okay, so that distance varies directly with your time. In just general math terms, a lot of times we see our y varies directly with x. When we have something that varies directly or it's directly proportional, that means we have a constant change. And knowing that we have a constant change, that allows us to create an equation. So our equation looks like this: y equals k times x. K is our constant of variation. So this sentence right here, this math sentence equation, says that y varies directly with x. And we'll use this equation a lot in the next few examples. So here's an example. The number of seconds varies directly with the number of minutes, which makes sense. If we have 120 seconds, that means we have had 2 minutes go by. And we're asked if we have 300 seconds pass, how many minutes does that come down to? So we're going to write an equation. This first sentence is huge because that is what allows us to write our math sentence. So seconds varies directly with minutes. So I'm going to use S for seconds. That K, constant of variation, is going to be there. So seconds varies directly with M, which is minutes. Now I'm going to plug in the information that I know. I know 120 seconds is 2 minutes, so I plug 120 in for S and 2 in for M. And I'm going to solve for K by dividing by 2. So I know my constant of variation is 60. Now I can plug in this 300 and figure out how many minutes is that. 300 equals, I substituted that 60 in for K into my original, and I'm solving for M. So when I divide, I get 5 minutes is the same as 300 seconds. Okay, here is another example. My distance traveled is directly proportional to the time spent traveling. So we have this motorized scooter that can travel 10 kilometers in 30 minutes, and we want to know how far will it travel in 45 minutes. So again, first sentence tells me what should my equation look like. So distance is proportional to time spent traveling. Plug in the information you're given. We have this pair, our distance and our time. So we plug that in for D and T. We solve for K and we get K is 1/3. Well, now I can use that constant in my original equation and plug in my 45 minutes and then solve for D. So 1/3 of 45 is 15. So you would travel 15 kilometers in 45 minutes. Since we've said that direct variation is the same or similar to direct proportion or directly proportional, we can create a proportion. So here we would have 10 kilometers over 30 minutes is equivalent to X, what we're solving for, kilometers over 45 minutes. You cross multiply, so 450 divided by 30 still gives you your 15 kilometers. So both of those ways are available to solve these direct variation problems. With that being said, I would like you guys to answer this question. When cost varies directly with what you buy, know that we buy 12 items for $78 and we want to figure out how much will 42 items cost. So please solve that.